Have you ever looked up at the night sky and thought, what's really out there? Billions of stars, countless galaxies, and in the shadows something so mysterious and powerful. It bends the laws of reality itself. Black holes, they're not just destroyers. They're puzzles, secrets, maybe even portals. Some are so huge, they could swallow our entire solar system. Others are so ancient, they formed before galaxies had time to even exist. And here's the strangest part. We don't actually understand them. Every time we discover a new one, it breaks the very rules of physics. Tonight, we're going on a journey from the birth of stars to the monsters that lurk at the edge of time. From the science you learned in school to the mysteries science can't explain. This is the story of black holes and the universe that breaks reality. Let's start at the very beginning. Almost 14 billion years ago, there was nothing. No stars, no planets, no galaxies, not even space or time. And then, in a moment we call the Big Bang, the universe exploded into being. At first, it was just energy. But energy cooled into matter, tiny particles, atoms, hydrogen and helium, the simplest elements. Gravity pulled them together, and for the first time, stars were born. Now here's something wild. A star is basically a giant nuclear reactor. Deep inside, the pressure is so strong that hydrogen atoms smash together to form helium, releasing energy. That energy pushes outward, balancing gravity's pull inward. As long as the star has fuel, it shines. But stars don't live forever. Small stars, like our sun, eventually swell into red giants, shed their outer layers, and end up as white dwarfs. But massive stars, and I mean really massive, they go out with a bang, a supernova. And when they do, sometimes there's nothing left to stop gravity. The core collapses, the star crushes itself, and if it's heavy enough, it becomes a black hole. A black hole is not really a thing. It's a region of space, a place where gravity is so strong, nothing can escape, not even light. That's why it looks black. There's an invisible boundary called the event horizon. Cross it and you're gone, forever. Inside, all the mass is crushed into a single point called a singularity, a place where our laws of physics stop working. It's like nature's error message. And black holes don't just sit there. They can spin, they can grow, they can warp time itself. Near one, clocks tick slower, space stretches. To an outside observer, you'd look frozen at the edge forever. Einstein predicted them, but even he didn't believe nature would allow something so extreme. Today, we know there are millions of black holes in our galaxy alone, and almost every galaxy has a monster hiding at its center. A supermassive black hole, millions or billions of times the mass of our sun. And yet, the more we look, the more they don't make sense. Here's the mystery. When astronomers peer deep into space, they're looking back in time. Light from distant galaxies has taken billions of years to reach us. So the further we look, the younger the universe we see. And what we found there shouldn't exist. Quasars. Quasars are powered by black holes so massive and so bright, they outshine entire galaxies, and some of them existed less than a billion years after the Big Bang. Take ULAS J1342 plus 0928, a black hole 800 million times the sun's mass, just 690 million years after the universe began. That's like walking into a nursery and finding a full-grown adult. There simply wasn't enough time for a black hole to get that big. At least, not with the rules we know. And then, there's TON 618, one of the largest black holes ever discovered. How big? 66 billion times the mass of the sun. Put it in the center of our solar system, and its event horizon would swallow everything. Not just Earth, not just Jupiter, but Pluto and beyond. And yet, there it is, staring at us from billions of light years away. Then there's the Phoenix Cluster black hole. a cosmic engine spitting out more energy than trillions of suns. If our sun is a candle, this thing is a blowtorch lighting up a city. Each discovery makes the same problem worse. These black holes are too big, too bright, too early. So how did they form? Did they cheat the system? Or are we missing a piece of the puzzle? Now let's talk about how these black holes are breaking our physics. First, there's the Eddington limit. It's supposed to be the maximum rate a black hole can grow. Feed it too fast, and the radiation pushes matter away, stopping it. But some of these monsters grew faster than the limit. They ignored it completely. Then there's the information paradox. According to quantum physics, information can't be destroyed, but black holes seem to erase it. If you throw a book into one, the book and the information in it is gone forever. That breaks quantum mechanics. Then we've got Hawking radiation. Stephen Hawking showed that black holes should slowly leak energy and evaporate, but we've never actually seen it happen. If it's real, black holes die. If it's not, physics has another hole. And then there's the singularity itself, a point of infinite density. Physics just stops. Relativity says one thing, quantum mechanics says another. Neither works. Every time we look at a black hole, it's like the universe is saying, "Nice try, but you don't get it yet." So how do we explain the impossible? Scientists have theories. One idea, primordial black holes, formed right after the Big Bang, when the universe was hot and dense. They could have been seeds for galaxies. Maybe some survived, hiding in the dark today. Another theory, direct collapse. Instead of forming from stars, huge gas clouds collapsed straight into black holes. That would let them skip the slow growth process. And then there's dark matter, the invisible stuff that makes up most of the universe. We don't know what it is, but if black holes can feed on it, they could grow much faster. And here's the wildest thought. Maybe black holes aren't just ends, maybe they're beginnings. Some physicists think that inside a black hole, a new universe could form. In other words, every black hole might be a Big Bang for somewhere else. If that's true, then maybe our own universe was born inside a black hole, in some other reality. Think about that. The end of everything here could be the start of everything somewhere else. So what does this mean for us? Our galaxy, the Milky Way, has a black hole at its center, Sagittarius A star, about 4 million times the sun's mass. Don't worry, it's 26,000 light years away. It won't eat us anytime soon, but in a few billion years, our galaxy will collide with our neighbor Andromeda. The two central black holes will spiral together and merge into an even bigger monster. And far, far in the future, black holes might be the last things left. Stars will die, galaxies will fade, the universe will go dark, but black holes will remain, slowly evaporating until even they are gone. It's a chilling thought, but also kind of beautiful, because black holes remind us that the universe is stranger than we can imagine. They are mysteries carved into space itself. Are they destroyers or creators, monsters or mothers of new universes? The truth is, we don't know yet, and maybe that's the point. So tonight, we've stared into the abyss. We've seen stars born and die, galaxies collide, and black holes that break reality. And the deeper we look, the clearer it becomes. The universe is not just stranger than we think, it's stranger than we can think. But maybe that's what makes it worth exploring, because out there, hidden in the dark, are answers we haven't even learned how to ask yet. And if black holes teach us anything, it's that the impossible is possible. So subscribe, because next time, we'll explore the strangest planets in the universe.